All right, thanks everyone for giving us your attention today. I know Zoom fatigue is real. I'm sometimes on 10 or 11 Zoom calls myself during the day, so understand Zoom fatigue. So appreciate everyone joining us today. We are talking briefly about face-to-face meetups. I'll probably try to get something probably September, try to do our first face-to-face meetup after the pandemic came about, but I'll still do a hybrid. I'll do a Zoom for anyone who prefers to participate from home, and we'll do it face to face just because some people are now comfortable, especially those of us that are vaccinated, kind of shaking hands and getting a little networking going on. So for those that don't know me, I'm Jeff Fudge. I started this user group maybe about 4 years ago. Was a big advocate of AWS in my roles as CTOs and CIOs. I now work as the AWS practice lead for Green Pages Technology Solutions and kind of live and breathe AWS, at least on the pre-sales and on the practice side, and not as hands-on or technical as many other are, but enjoy doing that work. I appreciate you joining us, and I'm going to kick it over to David Malone, an IoT Solution Architect from AWS here out of Tampa Bay. So David, it's all yours.
Hey, thanks, Jeff. And thanks everyone for being here today. Like Jeff said, understand what it's like to be on multiple meetings a day. So thanks for spending a little bit of time with us today. The topic here, let me go ahead and start to share my screen, is really kind of focused on AWS IoT for developers. So I've been engaging with a number of meetups throughout the region to kind of really find what developers think that they could use more help with, or just kind of show them the ropes from an IoT perspective. And I am Dave Malone. I'm a Senior IoT Specialist Solutions Architect with AWS. I've been there for about 4 years now. And I've worked with a lot of different customers in a lot of different industries and sizes of customers, everything from startups to globals. Primarily on IoT for the last 3 years. I actually joined as a generalist SA in the US Southeast, kind of here in Florida for a while, before transitioning to the role that I'm in. So let me go ahead and make this full screen so it's a little bit easier to kind of see what I'm showing you here. Today's topic is going to be around how to use Kinesis video streams with WebRTC, which is a really good candidate for kind of learning as our service enables you to build end-to-end low latency video stream IoT applications. This is not going to serve as really a holistic introduction to WebRTC as the protocol itself. But if you're familiar with WebRTC at all, you'll know that there's much more that you can do than unidirectional video streaming. But in general, the idea is, hey, maybe I want to build some connected cameras, either to apply them as a machine vision use case, where I also want to be able to pull up a live low latency video stream, or I want to build something along the lines of the Ring doorbell, right? So I have some sort of connected camera that's part of some home's surveillance solution that I want to enable, or of course you could go commercial with it and kind of target businesses with that as well. So that's generally speaking what we're going to talk about today. Let me just ask a quick question here. How many of you have even had any exposure to AWS IoT services in the first place? If you don't mind, you can unmute yourself and let me know, kind of yes or no.
This is Chris Green. I have.
This is
Yeah,
I have.
Okay. All right, cool. So a couple of you have. I see a thumbs down from one of you, so thank you for letting me know. And I won't have a whole lot of time. I've got an hour, and I do kind of fill a lot of the space here. But we very briefly touch on some AWS IoT service here, aside from KVS with WebRTC. And so I'm going to walk you through that, and I'll explain a little bit more in detail just to make sure that you kind of understand it. All of this is in the AWS documentation, and the code that we're going to go through today is part of an open source repository that we have for KVS WebRTC in the C SDK. Full disclosure, I am not a deep C developer, so if I can do this, so can you. That's the idea here. There is an equivalent JavaScript SDK that when I have more time to run through this with my audiences, I get a chance to actually show you how to build an Amplify-based front end, which allows you to kind of build the next level, which is, hey, I've got my web and mobile apps too that need to be able to integrate into the live video stream and being able to only access just your video streams in a multi-tenant solution. But today, we're just focusing on the device side. All right. And as I go through this, if you have any questions, feel free to ask. So don't be shy. Definitely want this to be as interactive as possible. No need to save your questions all the way through to the end. Really, to do what we're going to do today, these are the basic prereqs. I'm at an AWS meetup, so hopefully this isn't surprising that you need an AWS account to do things with AWS. But almost everything here, except for the KVS WebRTC piece, should fall under the AWS free tier. And then I'm using a Raspberry Pi 4 just because it's kind of a nice, cheaper device that still gives me a lot of horsepower to work with. I actually have the 8 GB of memory model. And so it has a little bit more horsepower for me to work with, which makes everything from compile times and all that go quite a bit more quickly. And I'll explain the thought process behind. We're going to go through this from a developer's perspective. And from that perspective, it's, hey, I just want to quickly get into my device. I want to build out some POCs. Excuse me. And then I need to think about how to bring this thing through to production. So as I continue talking about this demo, I'll explain to you, or at least give you an overview of how we think about taking this type of idea through to a full-blown production deployment. And integrating KVS WebRTC with our AWS IoT services is actually a part of that. So I'm going to be talking about that today. Finally, it does say that the camera module is a prerequisite. The SDK sample applications have the ability to generate kind of mock video streams. And so even if you wanted to get started with this on like an EC2 instance, it will actually generate some video streams. You can even upload your own kind of pre-recorded MP4s, and the SDK itself will look for those in a specific directory, and you can give it arguments so that you can kind of stream your own mock video streams until you have an actual device with a camera. All right, so those are the prereqs. What we're building today looks a lot like this. So since I am not actually building a front end, we're kind of emulating the end user. I keep getting these notifications here, Jeff, for some others that are needing to be admitted. I'm going to go ahead and admit them.
Yeah, sorry about that. They're not showing up on my screen for some reason.
Okay. Yeah. If I see them, then I'll just kind of click up there real quick.
I'll do the same thing. Yep.
All right. So the camera itself, what we're going to do at first actually is not this whole flow of what you see here from 1, 2, and 3. Initially, just to get up and running, the KVS WebRTC sample applications will use an AWS Access Key Pair to directly access the KVS service itself. Now, there are a couple of reasons why it's better instead to treat the device like an IoT device and give it an X509 certificate and allow it to obtain temporary scoped credentials to access other AWS services directly, which is what our credentials provider service does. There's other aspects of AWS IoT services, such as Device Defender, that we could use to help with operational and security monitoring of the devices themselves, both from the device side, if we wanted to incorporate the device, not the device client, that is an SDK, the Device Defender agent on the device, and add that to set up some custom metrics. But also from the cloud side, we can monitor the usage of the credential that we give to the device and alert automatically if all of a sudden, say that credential gets consumed and stolen and ends up connecting from somewhere in China. We want to alert on that sort of thing, right? We want to know that the device credential has potentially been compromised and send out notifications. So again, treating the camera-based solution here from the device perspective as an IoT thing gives us further capabilities that we would otherwise have to build ourselves. Another one that, again, I don't have time to go into this today, includes our jobs service. So how do I keep updating the software itself on the device? So through the AWS IoT device management services, I can enable and build on top of the demo that I'm going to show you today to allow you to even update the application that's using KVS WebRTC. Other applications on the device, I can perform over-the-air updates to update those things. Okay, so the other thing here is we'll just mock the actual video stream viewer. The KVS console itself does have a JavaScript-based client pre-built that allows you to go in and check out your video stream. So that's what we're going to be using today. The real-world solution would look more like this. And so this is actually implied in the previous one as well, but I didn't put a little browser client in there. What we're doing with KVS WebRTC, because of the specification for WebRTC, which allows us to potentially use stun, turn, and things like that to help with NAT traversal to allow for a peer-to-peer connection if it can be made. Otherwise, there's kind of some fallbacks that will occur, all part of how the WebRTC interaction works. We don't honestly do anything special in that regards except support the WebRTC protocol and the ability to kind of initiate and negotiate how we're going to connect, and then potentially allow this line number 4, which is, hey, we do want to actually establish a peer-to-peer connection for that really low latency. And when I say low latency, I've talked to some others at AWS that work in video at a much deeper level than I do. And so we're talking, pretty low latency. I'm going to say 1 second or less with almost no jitter in a lot of cases in the video stream itself. And so it seems very, very real time coming through from your device, which is awesome. The previous version of KVS, if you've worked with it, we have a KVS that does not use WebRTC. That stream from the device will go up through the KVS service. So it's always going up to the AWS region that you're actually associating your application with, and then it's going back down to the consumer. And so you can just kind of imagine you've got video stream packets that are going across basically the open network, whatever that possibly is, going into AWS and then going back out to whoever's trying to consume it. And so the latencies there in a lot of the scenarios that I've seen is really between 5 to 8 seconds of latency. And so you can just imagine if I pick up a doorbell type application and I try to see who's there and they've already walked away because they've waited for about 5 to 8 seconds. You won't realize that they're walking away before you have a chance to say, hey, wait, do leave that package for me on my doorstep, or whatever that looks like. So all that being said, let me introduce you really quick to the credentials provider service. And this is a built-in function in AWS IoT Core. It has been around for quite a while. And this architecture diagram was taken directly from our documentation. But the way that it works is you use your device-based certificate, or there's other ways to authorize with the IoT Core service, and I won't go into that right now. It is still going to participate in an auth N and an auth Z flow that actually happens through the AWS IoT device gateway. So it's going through a full authentication and authorization using what are called IoT policies to determine whether this device is actually even allowed to use the credentials provider service. There's a specific resource for that, and I'll show you what the IoT policy looks like. And once it gets past that, if you're familiar with AWS's STS service, this is where it's going to obtain those temporary scoped credentials, which allow it to then turn around and give you a temporary AWS access key pair that's scoped to the IAM role that is mapped in the backend. And I'll show you how that mapping works. Then you can make other calls directly to other AWS services using that temporary key pair. And so This is a fairly common pattern from an IoT perspective. In our architecture, you're just going to replace that AWS box today with KVS, right? And the IAM policies, the minimum policies that you need to actually interact from a KVS WebRTC perspective, I'll explain that as well. So that's all the slides that I have right now. Any questions before I kind of walk you through the steps to start building it? All right, so let's go ahead and transition into the live demonstration portion of this. I do have a couple of things ready for us to look at. Let me bring those over here. All right, so first of all, let me make this window larger. From a font perspective, if anyone is having trouble reading any of this, let me know. There are some CLI commands that I'm going to be running. Some of it's pretty rudimentary, but I'm going to try to do a lot of it in the AWS console and just kind of show you what I've done there, just to make sure that it's not completely mysterious, like, oh, what AWS CLI commands did he run and why? Some of this that I'm doing can be accomplished in CloudFormation templates using CDK, whatever you like in that regards. But first and foremost, I am actually remoting into my little Raspberry Pi. It's sitting on my desk. Unfortunately, I have kind of a mess in that corner, so my cords are tangled up. Otherwise, I'd just show you. It's a simple Raspberry Pi V4. It has a camera module on it. I can't remember what this one is exactly. I think this one has the capability to automatically switch between infrared mode and switching into a nighttime mode versus a daytime mode, which can be undesirable for some applications. So obviously you want to choose the right camera for the right application. This is a classic do what I say and not what I do. I have not reset the password from the default on this particular Raspberry Pi, so I'm getting all sorts of warnings from that sort of thing. First thing we're going to do, and since this was kind of one of those things that's a little more boring to watch, if you've got a net new Raspberry Pi provisioned, which I provisioned mine just this morning, I formatted the SD card, updated the latest version of Raspbian and so on. And then I ran these commands just to make sure that everything's up to date as far as the existing dependencies. And then the other thing I did is, yeah, there are some upgrades that I can apply, but everything will work as it is. There are a few dependencies that we need to make available just as far as a build environment goes. Not all of these would be wholly required if you have a built KVS WebRTC binary in C. But Git is kind of obvious. I need the Git CLI on here because I'm going to actually clone the KVS WebRTC repo, which I'll show you in a second. CMake is a dependency because the build for most of our C-based applications, AWS use the CMake build system. These other dependencies, aside from Python 3, which Python 3 is only being installed because I'm using the latest version of the AWS CLI. If you're not aware of this, about 5 days ago, what's today, the 22nd? So a week ago, the AWS CLI finally took the stance that we are only supporting Python 3 from now on. So there's instructions on the AWS website about how to get that upgraded, and would encourage you to begin using Python 3. And if you're not using the latest version of the AWS CLI, what you'll find is you might not have some of the calls that I might make in my examples in the AWS CLI available. It gets upgraded at the same time that new features go out. And so it's very rare that you'll find that the AWS CLI does not have support for a certain new feature or service. And so you always want to make sure you're updating and upgrading the CLI. The other ones here are all the GStreamer plugins. So the KVS WebRTC GStreamer examples do actually make use of the open source GStreamer pipelines to take video from either, again, a connected camera. You could actually build it to use network attached cameras to do things like the RTSP protocol or whatever other protocol that you might need to actually stream from. And I'll show you kind of where the GStreamer pipelines are defined in the sample apps so that you can make those changes. All right, like I said, because watching packages get installed is as boring as watching paint dry, I pre-installed those things just to make sure my environment's all set up. I was gonna say if that one doesn't run, I've got a couple of things to do, but that one looks good. Wanna make sure CMake is up and running and it is of the latest version. A lot of these dependencies are documented as to which versions you need on the GitHub repo, and I'm going to show you that in just a moment. The other one to make sure here is that we actually have the necessary OpenSSL version. So if you're building this on another distro of Linux, please make sure you're at OpenSSL 1.1.1. That is required to build this. Okay, so all of those things look good. I'm going to actually go ahead and clone the repo here. And I'll show you where this comes from here in just a second. But I want to get a couple steps running before I introduce you to the repo, because in particular, after I have the repo checked out, I'm going to start to run the CMake build process and then the actual make command to build out the sample applications. That takes a little while. So I want to kick those off and then we'll talk about all the other stuff. The other thing to note about this repository, you'll see I'm running a git clone recursive. And ultimately, there are submodules within this Git repository. A lot of those are things like an OpenSSL dependency and some other dependencies. Within the project itself, you can pre-compile these binaries and link to them ahead of time, and there's instructions on how to do that. There's a lot of actual options you can take when building these sample applications, and I'll kind of show you where those are. So first, we'll grab the repo, including all of its submodules. And then the only thing we're going to do once we get in here, we're going to move into that repos directory on my local file system on my Raspberry Pi. And then I'm going to actually create a build directory, and then I'm going to begin to build out the build scripts. As a project, you could do this off of the Raspberry Pi, but you need to make sure that for your target device, your target OS, architecture, all of those things, that you have the necessary tool chains installed so that you could build for that target. For embedded engineers, this shouldn't be a foreign concept. In my world, and what I deal with on a daily basis, it's just as easy for me to go ahead and just grab this directly on the device itself and compile it on the device itself. After I've built my binary, you can imagine I've got an application that's built for my target architecture. The idea would be to take that binary and to go ahead and take that and make that distributable, for devices that get built either at manufacturing time or however that works, so that you're not compiling it on every single device. But that's after you've had an opportunity to kind of build your actual binaries according to your application's needs. Our sample applications are fairly Spartan, and so they get the job done, but they're not meant to like take straight to production. So we would assume that you'd spend some time looking at the sample apps, shaping it according to your needs, and then building based off of that. All right, this is the part that takes a little bit. So let's go ahead and start to look at the repo. While this is building, just kind of keep that hanging out down there. So the repo itself, basically the instructions that I'm walking you through today are available right from the repo itself. It is under the AWS Labs organization on GitHub, and it doesn't use KVS as the short name like I do. I get tired of saying Amazon Kinesis video streams over and over and over again, although that is the proper name. It's easier for me to just say KVS for WebRTC. As I mentioned, there's some key features that you can become familiar with, especially the existing audio codecs that we support out of the gate. Some other interesting things about how we support stun and turn, whether or not it supports IPv4 and IPv6, and then also how to really crank down the install size for these things. The instructions I'm running through are right here, so that shouldn't be strange. Are strange to you guys right now, because I've already kind of shown you those. The dependencies that you need to install are listed here, and those are pretty much mostly the ones that I've installed The only other ones I installed, of course, were CMake, which they're pretty clear at the beginning that that's a build time dependency. If you are going to try and do cross system compilation, they give you arguments to support that thing. We'll get to these other steps in a few minutes. The sample applications, let me go ahead and start to introduce you to those. You'll see there is a samples directory. And this is kind of where those sample video files come from. Those just live right in the repo, so you don't have to go anywhere else to get them. So these are the frames that will actually get streamed if you don't have a real camera up there and running. Same thing with the H.264 sample frames. So then they give you instructions on kind of how to use these things. So they aren't very interesting to look at, to be honest with you, but at least they show a little bit of movement so that you know you're looking at something a little bit more live than just some still image coming through when you expect to see a video stream. The other thing here is there's a number of sample applications in KVS WebRTC vernacular. There is still this notion of what's called the master and the viewer. It's part of the specification, and so these file names, I believe, will continue to be named this until the specification is changed and updated. But anyway, the viewer, pretty straightforward, right? I'm someone that wants to view a KVS WebRTC stream. Master is the producer of the stream. And then what we have here is we have one that's going to use the GStreamer pipelines, like I mentioned before. And this is the one that we're going to be working with primarily today. Within this file, to me, the only interesting thing kind of worth looking at right now is the actual GStreamer pipeline that's defined. And since this is open source, you'll see there's a couple of things that kind of determine whether or not we're going to use a test source and or whether it's going to try to use a real video. And then there is an option to enable both streaming audio and video. In my example, I don't have a microphone hooked up. Plus, I'm talking to you guys anyway via Zoom. So I would maybe create some sort of weird echo scenario. But these are the pipelines. And again, if you've kind of worked with any GStreamer pipelines before, whether that's something simple like trying to set up a real-time streaming protocol interaction on some other Linux-based system to stream it over through like VLC, you should notice these are very similar, right? And since this is open source and since there's a fairly good community around GStreamer, you can find all sorts of things that you can inline into this. For example, one thing I'm working on right now is in conjunction with generating the live video stream as rapidly as possible, I also want to run an object detection ML model that will just do simple things like draw bounding boxes around objects that are identified. So I want to be able to basically augment the video stream. And the way I will do that and the way that I've been working on it is there's a binary that I'll produce that will be part of a GStreamer plugin, and I'll just add that in another place in the pipeline. So that's how that would look. So this would be kind of your primary place to come and add in other elements of the pipeline, to add in, maybe you want to change the kind of dimensions or the frame rate. These are things that you control on the device side. Same thing with the bit rate. Some of these other things that you're probably actually going to want to work with in order to get the application working according to the constraints that your devices are going to have to work in, whether that's from a general consumer perspective or in business scenarios where you maybe have more reliable hardwired internet access. So you'd come in and you'd fine tune that in here. And it does just actually use the GStreamer C-based SDKs to access GStreamer. So that's why you might not see like, oh, I asked the question at first. I'm like, why don't I see the typical GStreamer whatever at the beginning before it pipes into audio videos or auto video source and through the rest of the pipeline. But that makes a lot of sense actually, if you think about it, that it's just using the C-based SDK there. All right, I'm doing as much talking as I can to let this let this take a second to compile. Compiling is taking a little bit longer for some reason right now, but let's kind of keep going here. This is the primary sample application. And as I mentioned before, This by default is configured to use and look for an AWS Access key pair as environment variables. And the way that we configure this, let me make sure I have the right file here, because there's a couple pieces that might be in different files. Let's go look here. This is in samples, the samples header now. There were some changes I used to have to make in this common file, but one of our customers actually did a pull request recently that allowed us to way more easily make use of the AWS IoT credentials provider service. And again, as environment variables. But in here, this defines all of the environment variables that it's looking for. And then in that common part of the program, that's where they're actually looking to make sure that these environment variables are set. And if one is set versus the other, in particular, for us to just enable AWS IoT Core provider service, all that we're going to do is uncomment this single line, rebuild the program, and we're off to the races. We'll still have to actually provide, there's a couple of configurations that it's going to expect to be in there now, including some AWS IoT key material and things like that. So we'll make sure to set those things. For the sake of time, because I don't want us to sit here and wait until this is done, let's do this. We are going to go over to the AWS console. And today I'm going to operate primarily in the Ohio region. From a KVS perspective, let's just go take a peek here. See what regions the KVS WebRTC support is rolled out to. The way that we access the KVS WebRTC aspect versus the existing KVS kind of service functionality is under this signaling channels portion of the KVS console. And this is where you'll see our signaling channels will show up. And if you look in here, this will show us there will be grayed out AWS regions that aren't yet supported. If you find that there's a region that you really need supported for your particular application, please let someone at AWS know. This is how we help prioritize where we continue to roll out the service is based on your feedback as users of AWS. But that being said, let me go and set up a couple of other things. Let me show this diagram again. So like I said, from the device side of things, we're going to need a credential, and we'll generate that when the device is built and actually ready to do that. On the back end, though, there's an IoT policy that I need. There's an IAM role that I need. And there's what we call an AWS IoT role alias that allows you to go from kind of one type of credential to requesting the other type of scoped credential using IAM policies. So let's go ahead and create those things. From the IAM perspective, we're going to go ahead and create a role. And because I spent most of my life as a developer, I do not have a lot of really interesting naming conventions. So I'm going to create one called the KVS WebRTC device IAM policy. You are welcome to use more interesting naming conventions as you wish. In this case, let's see, do I have KVS in here? Kinesis, but that's not necessarily Kinesis video streams. Let's choose EC2 as our starting point. The next thing here is we do need to create a policy. That's the one that I actually just named a second ago. All right, so this one I can definitely choose the Kinesis video stream service. And instead of kind of poking around and getting all these right, I'm just going to copy a policy in here, a JSON policy. This is in the KVS WebRTC documentation as it pertains to incorporating AWS IoT Core. The thing to note here is we're going to allow you to do things both on the kind of Kinesis video resource type for stream and for channel. The other interesting thing here is we give you a special policy placeholder when there's an integration with AWS IoT Core for the credential that's being kind of provided will be associated with a thing name in the registry. And what this does is it helps with that problem of, I want to make sure that my device only has access to a stream with its thing name. So I shouldn't, from the device perspective, have access to any other live stream, whether it's writing data to the stream or reading from it, unless it has the same name as my thing. And I'll show you where the thing gets set up in the IoT console. So that's what this policy is doing. And we're going to go ahead and give it a name. That's not the right name. KVS Web RTC. Okay, go ahead and create the policy. And the other thing we're going to do real quick is create an IAM role associated with that. Oh, actually, now I should be able to just come in here and find that, that role I just created. Obviously, this is the type of stuff that you do once. You make sure that you've got it kind of created the way that it needs to be created, and then it's available. It actually does not set up anything to do. I'm going to adjust the trusted entities here as well in just a moment. The name here, KVS WebRTC device IoT role, and create that. Trusted entities, this should be fairly quick. What we're doing here is there's a specific principal associated with the AWS IoT credentials provider service, and that's what we're going to go and give it access to. Okay, and a trust relationship. The ideal way to create these is definitely CloudFormation templates, but like I said, I wanted to make sure that we're kind of showing you the steps, and these steps are documented. So I'm going to go ahead and update this because that's truly the trusted entity that needs to be able to call IAM to do the STS assume role call. And then we're going to go ahead and into the IoT portion of things. IoT Core is the right service here. There are a few other services now with IoT in them. And we're going to first create a device policy. And policies and role aliases are under this secure portion of the AWS console. And I've got a couple of policies here related to Greengrass and some other test scenarios I work on occasion, but we don't yet have the role alias that I want in place. So again, keeping my naming pretty consistent with the other things that I've kind of worked on is this is that role alias that's based on KVS WebRTC and devices for IoT. I'm going to switch to advanced mode, and I'm just going to go ahead and drop in the policy that I have already prepared, and I'll walk you through it. Okay, so the policy is, first of all, I am giving the device permission to publish and receive to IoT topics, even though it's not doing that. So I could effectively take this out. Same thing with the subscribe action. I don't need to be able to do that really, but in my mind, as I think towards the common aspects of what I want to build from an IoT perspective, I may want to use device shadows. So I might want to subscribe to that. I may want to use jobs. So I may want to subscribe to jobs-based topics. So I would continue to add other topic filters in here according to what the device needs to access. The important one today is that assume role with certificate action. And this is where I'm going to map to a role alias that I'm going to create that will actually allow my devices to map using their principal, the X509 certificate, to call that other alias. Then under role aliases, I'm going to actually set that up. And this part's maybe the simplest thing you may have seen so far. The named alias, the name of it's important because from the device side, I do need to actually know what this is. I need to specify it. And then of course I get to select the role that I want to alias. Well, that's unfortunate. What did I name that thing? Oh, it's because it's not IAM policy, it is device IoT role. There it is. All right, so that's it. It's literally just a name that maps to an IoT role. In order to be able to even assume this role alias, the policy has to allow it, and that's what we went and set. Let me just double check, make sure I said that correctly. Role alias, the role that I specified here, KVS IoT role alias, because if these don't line up, it's not going to work. Not the end of the world, but I want to make sure it's going to work the first time, and it won't because I got it wrong. Hang on a second. So let me edit this policy document. A lot of what I'm doing right now, like I said, is one-time setup. We're just preparing you for what we're going to do in the device, and there, that's done. All right, so this is done with the part of the build step. I'm going to kick off the next piece, which is just actually building the sample applications now. This doesn't take nearly as long, so we'll come back to that in just a moment. All right, so the trust relationship is established between AWS IoT Core and the IAM roles that I want to be able to call STS assume role on. And I have mapped that to a very specific IAM role that will only give the device the least privileged access that it needs to call into KVS WebRTC. So that's how you kind of control the scope of these things. The next thing we're going to do, sample application built. Now we're actually going to come in and set a couple of things. First of all, because the SDK was configured to first use an AWS Access key pair, I'm going to go ahead and set those. I had a pair already generated. Hopefully that's not mysterious to anyone as to how I did that. But again, if this is something that you are unfamiliar with, there's ways to do this through the AWS console and in other ways. The other thing here is we do want to make sure we set the AWS default region. These are pretty standard configurations when working with AWS SDK type programs. I am working in the US East 2 region. If you don't set this, it's not that the stream won't work, but it will default to the US West 2 region, I think. And so you may go into the console and ask yourself, I can't understand why this is happening. Where did my stream go? Well, you switch yourself over to the US West 2 region and you'll find it. So this is the way to just make sure that we're doing that correctly. The next thing we'll do is in the build directory. Now there's a number of things that got built, including some sample binaries, which includes that KVS WebRTC client master sample. This only has one argument to use, and that's a channel name. And so if you remember here, if we go back to the KVS console and we go to those signaling channels, we shouldn't have seen any, or if I have one or two in there, maybe they aren't named test channel. So first of all, there's no channels. I did give the device permission to go ahead and with the access key pair that I'm even using here, which is a different IAM user that I had set up with a different set of permissions. This one still has the same permissions, and that includes the ability to create a channel and to go ahead and start sending data through that channel and all of the aspects it needs to be able to do from a WebRTC perspective. So this is all getting initialized. We're looking good so far. And here, I refresh this and I now see a channel. And there's some interesting statistics we can get out of the channel as well. They give you some nice kind of getting started as far as how to potentially actually get started with what I'm showing you today, the SDK. And then they explain kind of, hey, this is how you can actually do the type of demo that I'm showing you here. But really the interesting parts are in the media playback viewer. So I've got my camera set up over here on my desk to my left. So we're going to go ahead and get it started. Back here, you can see there's some work happening as it's going through the ICE and remote candidate negotiation as part of the initialization of the RTC protocol. So there I am. It's fairly low latency. You can see hopefully both on the Zoom camera and on this camera as it's coming through the console, it's pretty low latency, right? And that's, of course, going to the Ohio region, but that all doesn't matter in this case because as far as I know, this is an established peer-to-peer connection. So let me stop that. As you might have noticed, the camera's upside down, right? So let's go fix that first. And again, since this is just a standard GStreamer pipeline, let's go terminate our program. If it's going to cooperate, there we go. And once the program is terminated, let's actually go back up and make changes to the sample application. And I told you before, this was in the client master GStreamer sample. So let's open this up. I'm going to use Vim. You could use pretty much whatever you really want to from that perspective. What did I spell wrong? Client master. Oh, that's fine. GStreamer sample. All right, so we're going to open this up. In here, that same GStreamer pipeline that I wanted to work with actually started with auto video source. So I'm going to find that in here. And right after video convert, I'm going to start to insert. There is a standard video flip method that I can call. And the method here I want to call equals rotate-180. And then I just need to make sure to kind of pipe it back out to the next part of the program. So don't forget that bang at the end. Save this, rebuild the program, which is way faster now, thankfully. And let's go rerun this. And you'll see that the video is flipped over. Once I refresh the screen here. There we go. So now here I am, no longer hanging from the ceiling. All right, so now that that's working, the next part of what we're going to work on is eliminating the need for those AWS Access key pairs. And I will get that done before we're done with our meetup here. There's only a couple more steps to operate at this point. So we've already got the kind of security policies established the way that we want to. The next thing that we really need to do is actually go and register the thing. But before I do that, locally, there is the need to set this variable. My Raspberry Pi, I just like to give mine names that make it easy to kind of keep track of it. So you'll see my IP address here. I'm just going to go ahead and not use that. That's not what I meant to do. I have kind of a naming scheme for my little fleet of Raspberry Pis, which is just to create an IoT thing name, knowing that that's what it was. I could instead create it with a kind of generated random identifier and then use this part of the aspect in the device registry, but I don't want to go into too much today. The other thing I'm going to do, just in case there is that thing group name that I might not have created yet, we do need to go create those. So in the IoT console, the next thing we're going to do is register a thing, and I need to make sure I use that same thing name. Create a single thing. Here's my thing name. I could actually do a whole bunch of stuff here. I don't want to do anything with shadows right now. They've upgraded a lot of these things lately. So the console actually has a lot clearer explanation of steps and what you're doing here. I'm not going to create the certificate here because if I did, I'd have to download it from my browser onto my MacBook and then SCP the files over to the Raspberry Pi. For now, since I have the AWS credentials and the AWS CLI over there, I'm just going to generate the certs right on the device because it's just faster. All right, my device is configured. I need to create a thing group. And the reason I'm creating a thing group is from an IoT policies perspective, it's pretty effective to actually create a group and apply policies to the group. And then policies, kind of like it works in most identity systems, policy is then associated to group membership, right? So that's the way I like to do things here. So let's add a policy in here. What was that policy name? Probably something to do with KVS, right? Let me just grab it over here so that I'm not fumbling through this. Manage policies, add policy. There we go. KVS, WebRTC device, IoT role alias I should have added policy at the end and not alias. But I'm going to add that policy and update the policies. So what it's showing you here actually, and it didn't used to do this in the console, these are the actions that it are allowing or denying. So it gives you kind of a nice way to see like, hey, what are the effective permissions in this thing group now? Now back to my thing, I'm going to come in here. I'm going to associate it with the thing group. Done, should be done. Yep. All right, now that that's done, the only other thing I need to do is go back to the device and generate its certificates. These are standard AWS CLI calls. There are ways to support more than just the AWS root CA as your signing authority. But today I'm just going to use the AWS root CA as the signing authority. I'm going to place my device certificates right in the home directory. You can place these wherever you want. Then it did output a certificate ARN. So you can see that real quick because I need that to attach. What I'm doing here is I'm actually going to attach the certificate to the device so it can be used as the principal for the device. And now the device kind of has everything it needs. The only other thing I need here, I did generate these certs. So I skipped showing you that part. They're here, standard kind of X509 certificates, public private key pairs, and a device certificate. The only other thing I need, that is not what I meant to do. My copy foo is failing me today. I need to download the signing certificate, the root CA effectively. This does come from our standard Amazon Trust repository. I'm going to download that. So that's all pretty straightforward. The only other thing I've got to do here is change that sample code like I showed you before, Amazon. And then this is under the samples directory. Actually, I don't even, yeah, I do need to go in there. I'm going to make one quick change to this, and that included the line that was commented out. That's not, again, this is just failing me today. Hang on one second. AWS IoT core enable. Oh, that would be bad if that actually didn't exist. I'm going to assume that I fat fingered that. Yep. All right, so uncomment that line. We're good. Again, rebuild this. Now it's actually configured to look for an X509 certificate instead of the AWS Access key pair, which allow me to kind of get past having to use those types of credentials. The only other thing I've done here is I'm generating a run script, and this includes all of the paths and sets all of those environment variables that I told you about. And one of the things you actually need is the special credentials provider endpoint that AWS IoT provides. This is different than the endpoint that we show you here. This is the standard data endpoint, which you can use to pub sub MQTT messages and things like that. So I'm actually grabbing that through just a kind of convenient script that I've generated here. I'm also going to change the permissions on this script, and I'll show you what's in there. Also just kind of check to make sure it actually worked. I'm setting a default region because really the KVS WebRTC sample app is going to want that. I'm setting a thing name because that is actually specifically going to be expected now in the sample application, and that is what it's going to use to generate the KVS signaling channel name. I got the credentials provider endpoint. Here's that role alias that is needed. It's just part of the integration with the credentials provider endpoint. I've got my certs. This is the minimum stuff here. I've also got my linked library paths here just in case it's actually needed. I think I have found that it's needed before. And then you'll see here, I actually just end with a call to the same sample application. So I'm just going to go ahead and call run KVS WebRTC. If everything worked, this hopefully is not a problem. Otherwise, I can go clean that up real quick. Let's go see if it got created. Let's go see if it's working. It's not going to look any different, by the way. Yeah, this is failing to connect. And it's because I need to remove this file here. Give me just a second. Is this a directory? No. Oh, bummer. All right, so I have hosed something up here. This should work the first time. I'm gonna have to go figure out why this particular piece is not working. It should have just been this signaling cache directory that I had from kind of some previous uses of the KVS or RTC on here. But I'll have to figure out why that's not working. The signaling stream though is exactly the same, right? It's what you'd expect. The key difference here is now I don't have to have an IAM user per device. And there are limits on the total number of IAM users that you can have in an AWS account. I can take advantage of using the credentials provider service, which may also allow me to do other interesting things like take still photos on the device, take maybe even recordings on the device while it's offline and save them and upload directly to S3 at a later time, right? So I could extend the IAM policy to allow the device to be able to access S3 directly or other AWS services directly. So I got through that as quick as I could so that we could end on time. I know I didn't leave a whole lot of time for Q&A and I apologize, but if you guys have time, I'm definitely have a little bit of time here to stick around to answer any questions you have.
All right, any questions from anybody? If not, with that, David, certainly appreciate the deep dive. I was struggling to keep up with my little pea brain, but great information. Appreciate that. Thank you, everyone, for your time and attention today, and I hope you all have a great afternoon. Thanks so much.
Thank you, everyone. Thanks, Jeff. Bye, everyone.
See you.